Okay, welcome back everyone. I understand there may be some people that are kind of new that are joining us halfway through, so I've had a request for a bit of a recap. I will do that very quickly, and then we're going to jump back in right to where we left off. So if you are just joining us, there are two things that you need. One is the slides. There's a link here to get those slides. Just be aware that purrr has 3 R's. And then the other thing you need are 2 packages. Oh well, more than 2 packages, but library tidyverse gets you lots of packages, including purrr, and then this recursive package off GitHub will give you some of the data sets that we're using in this tutorial. So hopefully everyone that's new will grab those requirements, and I'll move on. So what have we done so far? We've essentially talked about solving. Yeah. Oh, you're going? Yeah, I'll wait for you. Okay, thank you. So we've talked about solving iteration problems with these map functions in purrr. And so far we've really concentrated on one function called map that lets us iterate over the first argument, .x. And we've talked about how we specify what we want to do. What else do I want to say about that? Let me skip forward to these examples. So essentially what map does for us is it lets us, for each element of the first argument .x, do something, and that's specified by the second argument .f. And we kind of had these little emoji examples where to each cat we could give it a fish. Map has some variants that just change what the return object is. So walk is one of those variants that returns essentially nothing, although it is doing something behind the scenes. But there is map_int and map_double for when you want to return like a vector of integers and doubles, etc. So what we're up to now is so map kind of solves this problem for one object that you want to do something to each element. Maps the kind of person to do it. If you have now 2 objects and you want to iterate over both of those objects and do something with those 2 elements, map2 is what we're talking about now. So we kind of got to this point where we'd seen this code. So this code is sort of an example of something that's quite common where we've got multiple files containing data. We want to read them each in turn. We do some manipulation on those data sets, and then we combine them all together to get a data set at the end. And we started to talk about how we might leverage purrr to do this in a way that kind of removes all that duplicated code and makes it less likely we make mistakes. So with that, I'm going to quickly review where we got to, and then I'm going to jump in. But before I do that, are there any questions? Does anyone need those links again that is just joining us? No? Okay. So we sort of had this example code that was very duplicated, had a lot of repetition, and we talked about how we could remove a lot of that repetition with what we've already learned about map. So let me just go over that again. So I created this months vector. It's just a character vector with Jan, Feb, and March in it. I created a files vector just by adding a .csv to each of those strings. And then we used map. And for each file and file, so each of those file names, we're just using the function read_csv. So this is an example of specifying that .f just by giving a function, just passing in a function. Read_csv, if you haven't seen it, is in the reader package that's also part of tidyverse. It works a lot like read.csv with a few changes. So sales_list is now a list. It's the same length as what we passed in files, so it's a list of 3. And each element in sales is the result of the read_csv. And read_csv always returns a tibble, or at least a data frame. Don't quote me on that. But that's what's sitting in each of those elements. Now, the other part of what was happening in the previous code is there was some manipulation of each of those data sets before they got combined together. So that's the bit now we're going to try and do with map2. So what was happening? Well, each of those data frames got a new column added, and that new column was called month, and it had the value just repeated on every row of that month. So the January data set should have a column called month that has Jan repeated for every row. And we're going to do this sort of utilizing the same strategy. So we're going to do it sort of once. We're going to solve the problem. Then we're going to turn it into a recipe that's going to form our .x argument. And then we're just going to put it together with that map2 function and do it for all these files. Okay. So let's we already have pretty much this problem solved for one element because we had it in the code. We were doing it for each element separately. And one way to think about doing that for the first element is to take, so here I'm taking the first element of sales underscore list. So remember, that's that list of data frames. This is the first data frame. Right? I'm mutating the first data frame. And what I'm doing is I'm adding a column called month, and its value is the first element of my months vector. Remember, the months vector was that very first vector I created. It just had the character strings Jan, Feb, and March in it. So to add a column to the January data frame it's called month and has the value Jan, I'm mutating the first data frame in the sales list, and I'm adding a column called month, and it takes the value that is the first value in the months vector. Does that make sense to everyone? Cool, great. So the sort of key thing here is that I'm now iterating through two objects. Here I've just kind of pulled out the first element of sales list and the first element of months. If I wanted to do this again for February, I need to change both of those indexes. Right? I need to jump up and say, okay, now do that with the second element of the sales list and the second element of the months vector. So this is sort of exactly what you want to use map2 for. Now we're iterating over two objects. And the way it works is very similarly. We're going to use this shortcut where we specify a formula for what we want to do. And to specify a formula, the first thing we do is we add that tilde in front. And then when we're talking about map2 and this shortcut, not only do we get a .x that we can use as a placeholder, but we also get a .y we can use as a placeholder. So the .x placeholder corresponds to an element from the object you're passing in as .x, and the .y serves as a placeholder for an element from the object that you're passing in as .y. You basically have to replace those two objects with .x and .y, right? Instead of talking, let me go back to what I had there. Instead of talking about a specific element in sales list and a specific element in months, I'm just using those placeholders .x and .y. So take an element from sales list, we're going to mutate it by adding a column called month, and that value is coming out of the y object. Now the order matters here, so you kind of have to remember that I just replaced sales list with .x and months with .y, because that means I need to specify sales list as the .x argument and months as the .y argument. But otherwise it's pretty much the same. I'm going to use map2. I just have to specify .x and .y. The third argument is now my .f, what I'm going to do. And then for some reason I've changed the name of that. It was weird. No one caught that typo last time I taught this. So. Okay, so I'm specifying the sales list as .x, so that's the list of data frames. .y is month, that's the vector of month names. And then .f is this, take each one and add this column month. So sort of all I have to do, let me go back a step, so not quite that far. So the result, remember, map2 is always going to return a list. Because .x and .y have to be the same length, it's going to return a list that's the same length as those two. So both of those objects of length 3. The result of this will be of length 3, a list of length 3. Now each element is that result of this mutate statement. That's a new data frame with this additional column tacked on. So the result of this is now a list of length 3 of all the data frames we wanted. All what's left to do is to kind of just stack them on top of each other into one object. And you can do that with the bind rows function. I believe that's in dplyr. That just takes a list of data frames and stacks them on top of each other. So this is kind of this is what that code would look like if we did it more in the purrr world. Rather than all that kind of copy pasting and editing, we've kind of extracted away that iteration, and purrr, our map and our map2 are doing all that iteration for us. The big advantage being, of course, that if we suddenly decide we need to do not 3 months, but 15 months, this is the only line we'd need to change. It's going to get a little bit more complicated if these files are nested in directories that correspond to year or something like that, but the principle is the same. Okay, so I want you to practice now using map2. So you're pretty good with map. Let's try something with map2. We're going to use a different data set in that recursive package. There is a data set in there called gap_split. It's a, let me run this and just talk you through that before I let you loose. So gap, so gap_split is a list. I just called str on it there to take a look. It's a list of 142, and each one of those elements corresponds to a country. Working with all 142 is a little bit unwieldy just in terms of time and output for you guys. So we're just going to work with the first 10. So the first thing that I want you to run here is this. It's just pulling out the first 10 countries. That kind of doesn't change anything that we're going to do next. So all the code we're going to talk about, you could run with all 142 countries. It just takes a little bit longer. So that's kind of irrelevant, but just so you know, you're going to work with a list that's only got 10 elements. Each element is a country. They happen to be the 10 countries with the first in the alphabet names. And then the other thing I'm going to do is I'm going to just create another object, countries, that has the names of those countries. So let me just run that too. This isn't anything too surprising, but these are the 10 countries we're talking about. And it now seems appropriate that Belgium got into the cut, but I didn't think about that beforehand. Okay, so here's a task that I want you to do. For each country, I want you to create a plot, and I'm going to specify a ggplot plot, and I have a hint if you're not familiar with ggplot, of life expectancy through time, and I want that plot to have a title, the title being the name of the country. And this was something I forgot to do. I'm just going to ignore the code for a second, pretend that never happened. I just want to show you the plot. This is the kind of plot I want you to come up with. Right, for every country, I've got life expectancy on the y-axis, year on the x-axis, and I've titled it with the country's name. So I want you to use map2 to do that. I want you to try and implement the same strategy. So try and do it for Afghanistan first before you try and use map2 to do it for all the countries. If you're unfamiliar with ggplot2 or you don't want to worry about how to make the plot, the next slide has that code for one country. You could just focus on trying to turn that into a map2 call to do it for all the countries. And I'm going to give you 4 minutes, 15. Well, we can take as much time as we want at this point, but let's say 5 minutes then. So take a go, and in 5 minutes, I'll walk you through it. Okay, that was 5 minutes. Can I get a show of hands of how many people managed to make the plots? Who hasn't quite made the plots? Just a couple, okay. I'm going to go through it. I'll kind of work through how I might have done it. So I'm going to use the hint. So that could have taken, I admit that could have taken a little bit of time if you didn't use the hint. So here I am creating that plot for one country. So the kind of key things here, I'm using ggplot and I'm passing in one element in the kind of list of data. So the first element in gap underscore split, except I should be using gap underscore split small. Right, the first element is that data frame for one country. So you might want to take a look at that. It's a tibble, so if you're not familiar with tibbles, they're just like data frames, but they have a few nicer features. In this case, there's a country column with Afghanistan repeated many times, continent, year, life expectancy, and population. So I'm really looking for a plot of this year column and life expectancy column. I won't go too much into the ggplots2 syntax, but the sort of first two lines achieve that. And then I'm going to add a title. And the way I'm going to do it here, I'll talk a little bit about this in a second, but I gave you that countries object, and that had all those country names. I want to use the first one. Because I'm talking about the first data frame in that list, I also want to use the first country in this countries object. I'm just going to use the first one. So these are the two objects I'm iterating over, the gap slit small and countries. And I'm going to come back to that in a second because I think that can be a source of questions. But let me kind of complete the task first. So one of these has to be .x. I'm going to use map2. Let's just say .x is gap split small, which means I can replace that first element with the placeholder .x. .y is going to be my other object I'm iterating over, in this case countries. So I can replace that with .y. And then of course I need my .f, which I've basically already written. You just fix up the indenting a little bit so you can see it more easily. I just need to make sure that it's being interpreted as a formula by putting a tilde in front. And then let's hope that I did it all right. So it's actually kind of spitting out all those 10 plots as it goes through, and then we can kind of, if you're in RStudio at least, click back through them and see that we did indeed generate those 10 plots. Now, I think one thing that can kind of, I think this is what I get this question, and I totally agree with what people say. If we go back to that first, doing it for one element, you could argue, I think, and I think it's a reasonable argument, that instead of having this second countries object that just had the name, I could probably pull that out of the data frame. Right, I could probably take that first data frame, pull out the countries column, or the country column, sorry, and then just take the first one because I know it's the same for every row of that particular data frame. Then you're really only iterating over one object. You could use map. I think that's totally legitimate, and you could do that. I struggled a little bit to come up with a nice map2 example using some data we could access, so that's kind of why I did it this way. But if you're thinking, oh, I could do this with just map, it is true you could. Okay. So let me grab that code again. There are a few other things I kind of want to talk about here. That indenting is not particularly nice. Okay, so map2 here is running that function, and when you do a ggplot, sort of the default thing is that it prints out to the graphics device, and we're seeing those plots and we can scroll through them. But it might be nice to actually kind of keep those plots, right, to save them. So we might prefer instead to sort of assign the result of this map2 to something called plots. And then if we look at plots, If you do that, you won't actually see any output come up on the graphics device. But if you look at the structure of it, let me restrict that level a little bit and scroll through the reams of output. You'll find that what you're getting back is a list. That list has the same names as the original list, which is the names of the country. And now each of these objects is actually a ggplot2 object. So we've saved the ggplot2 object into this list called plots. So plots is now a list of the same length as our original. It's of length 10, and each element is the sort of specification for one of those ggplot2 plots. I think this is sort of more what I would do in practice, rather than, especially if you're doing this with all 140 something countries, you don't really want to waste time having it print 148 plots to the screen while you sit there and wait. And you can, of course, still look at those plots by calling up a specific one. So plots 1 is that plot of Afghanistan. The other reason that that's useful is that there was a second task on that slide that if you got bored, you could try and figure out how to save all these plots out to files with an appropriate name. So if I was doing that, and that's kind of another map2 task that I want to walk through. So if I was doing that for one of these plots, let's say the first plot, I might use ggsave, and I always forget because it changed some point in ggsave's development which order things go. Okay, so ggsave, file name equals something, plot equals something. Okay, so I know what plot I want to save. It's just going to be the first element in that plots list. I want a file name, and I'm just going to kind of create one on the fly by taking the first element of country, so that's the name of the country, and just tacking on .pdf. Do all my brackets line up nicely? I should check. I should probably reveal my file structure, and I did indeed get an Afghanistan.pdf with the right plot in it, right? So that's sort of solving it for one country. I could save that one country out to file. What I really want to do is save all those countries out to file. So I can kind of do the same thing. Now I need to translate this to a map2 statement. So I've got my map2, .x can be countries, which means I can replace the first element of countries with that placeholder, .x. The second element that I'm going to iterate over is going to be plots, so I can change that first element of plots to a .y. And then my .f is essentially what I've got here now with the addition of that tilde because it's a formula. I'm going to indent that. I'm just going to indent that to line up with the ggsave right now, just so it's clear where that belongs. I need to close the final paren for map2. So I could run that. And I should now, in my files, have one plot for each of those countries. So that's I find personally that's a pretty common thing that I do, is that I want to kind of save out to disk one thing for each element, and here we're doing that with plots. I think you could argue that, ggplot has facets. We could have just made all those plots with one ggplot call, which is fine with 10 countries, but imagine a faceted plot with 148 facets. Unless you have a really, really big screen, you're not going to see anything. So it can be useful to kind of have those plots individually. Although I think you could, again, make this argument that I might have been able to do that with map if I'd been a little bit more clever. But for illustration. Okay. Oh yeah, so the other thing that I didn't actually say there is that if you did have those all saved in plots, right, if you just type in plots, it works. Okay, ignore what I said there. You could just type in plots. Okay, any questions about map2 in the front? Yeah, so the question is what happens if you've got more than 2 objects to iterate over, like this.
Especially if the lists are different size, so one is 1 to 12, the other is 1 to 100, the next is 1 to 5.
Yeah, and if there,
What happens if you have to leave things out because you know there's a mistake in 47 and you want to leave 47 to 53 out?
okay, great. That's like 3 questions. So I'll go through them in turn. So first, what happens if you have more than 2 things you want to iterate over? If you have 3 things, there is not a map 3, but there is a pmap. So pmap is a function that will handle iterating over any number of objects, but they all have to be the same length. And I'll talk briefly about that later. The next question was what happens if they're different? The objects you want to iterate over are of different lengths. And in the purrr world, it's up to you to make them the same length. So if they're different lengths because you want to kind of repeat one setting or one element of one for some chunk of another, it's kind of up to you to kind of repeat that to make them the same length. Say that again? Yeah, if you pass in things that are different lengths, you'll get an error. And there are some helping functions in purrr to kind of help you do that. So if you're familiar with expand.grid and base, that kind of helps you take vectors and come up with all the combinations. There's a similar kind of expand function for lists in purrr. And then the third question was, what happens if you know, like element 48, you're going to get an error and you don't want that to stop that getting the results for elements 1 through 47. And there are other functions to help with that I'll talk about later. Okay, there was another question though somewhere in the other. You're good? Okay, great. Yep. Like one of these? It's just one of those plots. Okay. And if you are following along and you did that and then you're like, I do not want all those PDFs sitting around, there's the code to get rid of them. That's all up on GitHub. I'll let you go there to find it if you can't find it. Okay. Okay, so we're going to take kind of a little bit of a switch in gears here. We're still talking about purrr and map2, but one of the things where purrr comes in handy is when you're dealing with list columns. And I'll have to probably explain. How many people are familiar with list columns? Can I see? Okay. Not an insignificant number, that's good. If you're not, that's fine, we'll talk about it in a second. But the general idea is we've sort of been working with the Star Wars data that's in this hierarchical list. And I hope that for most people, sort of the first intuition is this is data. And in R, data most often lives in data frames, especially if you've kind of internalized the whole tidyverse perspective. And the big reason that data should live in data frames is it kind of forces you to keep that correspondence between variables measured on the same observation and doesn't let you kind of get mixed up and start pulling the height from the wrong person when you ask for it. And in data frames, we think about the cases or the observation in rows and the variables in columns. So just to kind of get you thinking about that, I want you to think about that Star Wars people list again. And think about how that might look if you had to put it in a data frame. And I'll give you 2 minutes just to kind of talk with your neighbor about what you think should be the cases, so what should be the rows, and what should be the columns of that data frame. Okay, your 2 minutes is up. So I'll ask kind of the easier question first. What is easier? I don't know. What are the cases? What should make up the rows? What should a row be if this was in a data frame? Does anyone want to volunteer? Yeah, a character. So each row should essentially correspond to a person. They're kind of the cases or the observational unit we have here. And then what would be the columns? So, yeah, the characteristics of that character. So we have things like we can have a name column, we can have a, I forget, let's have a look. So we can have a name column, we might have a height column, we might have a species column, that kind of thing. The place where this gets a little bit tricky in this sense is that some of these characteristics we have for these people aren't just sort of a single number or a single string. It makes it a little bit harder to think about it in a data frame. And this is where kind of list columns come in. So we've got each row is a character, a person in our SW persons list. So it's this data frame, or I'm actually going to use a tibble, is 87 rows. So that corresponds to our 87 characters. And I'm just doing a kind of a small subset of some of these characteristics here, so just 4 columns. So films is one of those characteristics we have where we get sort of some unknown number of values. Some of these characters have been in one film and we get one film URL. Some of these characters, like Luke here, has been in 5 films, so we get 5 character strings in a vector. And this is where these sort of list columns turn up and can be useful. So a list column is simply a column in a data frame where each element is a list. So normally in a data frame, we think about a column as a sort of an atomic vector, like the simplest kind of object. It's a vector the same length as the number of rows in our data frame, and it's either an integer or a logical or a character. So list columns aren't really kind of violating that rule because a list is a vector in R. It's just that it's kind of recursive. So we still have a list. This column is going to be a vector. It's a list. It's going to have the same number of elements as there are rows in the tibble or data frame, 87. But each element now can be something more complicated. In our case, for this films, each element is going to be a character vector. So this can be it can kind of feel a little strange when you first see this. It's sort of it's not really new, but there's a whole lot more tools that kind of help you deal with this kind of structure. So this films is what we call a list column, and I've put it in a tibble. So tibble is another package in the tidyverse that provides these objects called tibbles. And tibbles are just data frames that have a few nicer properties, one of which being it's easy to create list columns and it's easy to kind of provide some, I'm not actually sure this is entirely tibble, this might just be in base R2, that you can print it. It's not particularly useful output, but you can see that this is a list column and that each element is containing a character vector. So we could think about this, rather than working with this complicated hierarchical list for these characters, if we want to do anything with this data afterwards, we probably want to think about trying to get it into more of a data frame shape, 1 row for each person, and it might mean that some of our columns have to be list columns just to capture the entirety of that data. Question? Yep. Yeah, that's so. I think the kind of act of now. Let me. I see what you mean. Yeah, so do you mean, for example, that like here, every element is a character string? Do you mean could one be a character string and one be a... Got it. Yep. Yeah, so what we've got to talk about is how we get it into this form. And that's a really important point, that the process of getting this complicated list into this form could be complicated by the fact that some of our people don't have all the same characteristics measured on them. So we kind of have to make a decision, well, if Luke doesn't have a homeworld listed, what are we going to do in the homeworld column for Luke? Yep, and we'll talk about that. So far, like all I'm kind of saying is list columns exist. We should probably be putting our data in a data frame, and some of our columns are going to have to be list columns just because of the nature of some of these variables. Okay? Okay. So the kind of good thing is that purrr can help you get from that complicated list object into a tibble. So it really helps you with that step of taking something that's not a data frame and getting it into something that's data frame-like. So I'm going to kind of show you now how I went from that SW people list and came up with this tibble that I just showed you the output for. Okay. And to do that, I kind of have to tell you a little bit about tibbles. So the tibble package provides this function called tibble, and that creates a new tibble. And it's the syntax is very similar to the data.frame function. So if I was to create a new data frame, I'd say data.frame, and then I'd give column names equals, and then pass in the data and comma, and then another column name equals, and so on. So a tibble is just the same. So I'm going to create a new tibble, and I've kind of pre-filled this out. I'm going to have a name column, a films column, a height column, and a species column. I just have to figure out what I'm going to stick on the right-hand side. What should the name column be? Where is it coming from? And I'll just kind of go through these in turn. The sort of name is the simplest one, right? I'm pretty sure we've already done this a few times. We're basically just pulling out the names from that SW people list. So I'm taking SW people, I'm passing it into map as the .x, and then I'm using that string shortcut to pull out the name. And I'll just I just want to kind of show you that there's nothing kind of tricky there, that if I ran that code, it is just a vector, a character vector, happens to have names that are duplicating the contents, but it's just a character vector. That's going to be one of my columns called name. Similarly, well, this is a little interesting. So that was the simplest case. The output I got there was a character vector. I could have stuck that in a data frame. There's nothing kind of crazy going on there. For the films, I want to do a similar thing. I just want to pull out the films characteristic of each person, so I can use map, I can use my shortcut. But remember, map returns a list. So the output of this next line, if I just ran that, it's going to be a list. So it's a list where each element is a character vector with the films that character has been in. And that is what gives me that films column as a list column. Because I'm passing in a list, that list has got 87 elements, just like everything else I'm passing in, that gives me a list column. So if you use one of the typed functions, you're going to get a normal column just like you're used to. If you use map, so the untyped version, you're going to get a list column. And then these other two examples are kind of just other things you can come across. So, for example, the height, like the mass we saw earlier, what you get back is actually a character vector, and you really want to do a little bit of manipulation to make sure that that's being interpreted as a number. So here I'm kind of just increasing the pipeline a little bit and adding on that pass number. where a missing value is coded and that character string is unknown. And then the other thing, this kind of goes back to the question, well, what happens if, for example, species isn't in every person that I have in my SW people? And in fact, it isn't. And the map functions have this argument .null where you can specify what should be returned if the element is null, if it's not there. And here I'm specifying I want a missing value. I'm being a little bit more specific than that. I'm saying I want a missing value of the character type, this is, because I'm using map character, I'm expecting a character string. I just need to make sure I'm getting NAs that are also of a character type. Okay, so that, if you run it, and I will, is how you get that people tibble. Okay, so there's my names, just normal column, character column. Films is a list column, height's a double. There's another variable that I'm not showing, and 77 more rows. Right, so purrr is quite useful for taking kind of complicated hierarchical structures and pushing them into our more usual rectangular formats that we handle in R. Okay, then the other thing that purrr does is it makes it quite easy to work with these list columns. And now we're sort of combining purrr and dplyr together to work with these list columns. So you might kind of notice, like, this list column, the data is there, it's not particularly easy to see, and it might be that we don't really want the original data, we want, a new column that's some kind of summary of that data. So we need to be able to manipulate that list column to work with it. Okay, so I'm going to kind of work through this code. So I've created this people tibble, and I can pull out that list column, right? If I want to see what's in it, and I don't want that kind of tibble summary that just says, this is a character string of length 5, I can pull out that column just like I would pulling out a column of a data frame, and I will get back that it's being displayed as a list because it is a list. It's even a named list, and then I can kind of see what's inside each one. So that's what that films column is. It's a list. And we now have all these purrr tools that help us work with lists, so we could iterate over each one of those elements and do something. So when you combine that with mutate, you can kind of start making new columns that are transformations of those more complicated list columns. So do I highlight things? Yeah, okay. So the kind of important thing here, I'm using mutate to create some new columns. So I'm kind of relying on dplyr for that half of it. But the part that's going in on the right, so who's not familiar with mutate? Just a couple of people. Yeah, that might be too long a description. How can I simplify it? I can just tell you. So mutate, you pass in a data frame, so I'm passing in people_tibble. And then kind of like data.frame, you can specify new columns by giving a name on the left of the equal sign and then what that column should be on the right-hand side. The big benefit being you can refer to other columns in the data frame without having to preface them with data frame $, whatever. So when I say mutate here, I'm creating two new columns, one called film_numbers, one called n_films. And in both on the right-hand side, this films here is referring to the films column inside the people tibble. Remember, films is a list column, so it's a list. So again, I'm using purrr to do something with this list. For each element of films, in one case, I'm using a lookup, which I haven't defined here. That was naughty. But I'm looking up kind of what number the film is. Rather than displaying those URLs for the film, I just want to know, is it film 1 in the series of 9, or is it film 5? Or in the second case, I'm for each film asking for the length, so how many films are there, and returning it as an integer. So the key thing here is that when you're combining dplyr with purrr, if you're using a map inside the mutate, you're going to get a list column back. Right? Map always returns a list, so that column is going to be a list column. If you're using one of the typed ones that returns a vector, you're just going to get a normal column. And hopefully so this is kind of the slide that you can actually copy and paste. It has everything you need. I'm just going to run all that code that created the new columns, film numbers, and in films. And I want to show you, I could just print it. It's not that useful because Sybil has this feature that won't show you all the columns if they don't fit, but let me just show you that they do exist there. So I'm going to select film numbers, the film numbers column, and the in films column. And I'll just do that for now. Spell it correctly. Thank you. So those are just those two columns. Remember, I created film numbers with maps, so I got a list column back. Again, you know what's inside that element, but you don't, you know what kind of thing is inside that element, but you don't actually see the data. But this in films was created with a typed version of map, so I just get a regular column back. Okay, so all of that was a little bit, you follow what I'm doing. Now I want you to try it. So you will need to copy and paste that entire chunk of code. And then what I want you to do is create, so using mutate from dplyr, create a new column that collapses the film numbers into a single string. So the problem with this film numbers column is it's a list column and I can't see what's in it. I want to just be able to glance at the data frame and see which films Luke has been in. So I essentially want you to take that numeric vector and just turn it into a string representation that tells me those films. And hopefully you know about paste. That'll help you do it. So I'm going to let you work on that for 1 minute. Is that a suggestion? Okay, let's say 3 minutes. There's a lot to internalize there. I can. Yeah, so this is kind of the point where you really need to have the PDF of the slides because it will take you more than 3 minutes to copy what I've got. So if you haven't done that, you're going to you can write your code without being able to test it. Or you can copy and paste this. And let me just add the instructions to that slide. So you can see it all. Okay, that was 3 minutes. So let's, I'll kind of walk through this one because I think it can be a kind of it can definitely be a tough transition to make. So we've got this people TBL, that's what I defined. And I'm going to try and make a new column. And I think I even gave you a name. Did I? No, but let's call it films squashed equals. So far this is kind of just standard dplyr syntax. If I was just dealing with a normal column that I wanted to make some kind of edit to, so let me just kind of, as illustration, if I wanted to take in films, and I might as well just do this with a similar kind of example. So I'm going to take in films, going to pass it to paste with the string films, right? Nothing here is purrr, it's all just dplyr. And then I could have a look at, I'm going to pull out the name column and the films squashed column. All right, so this is just straight up dplyr. I'm just making a new column called films underscore squash that was manipulating an old column that was a integer. Right, so that's dplyr. That's not what the task was. The task was to take those film numbers and stick them all together. So what I really want to be doing over here in my, well, I'm just going to get rid of all of that because it's not quite relevant. What I want to be doing over here, though, is some manipulation to the films column. Except that I know films is a list column. So I can't just kind of paste, like you can't just do something like paste and take the films column, although I've never tried. I mean, it does something. Huh. It actually does something pretty reasonable, too. I've never tried that. I guess you might not need to use purrr on this specific example, but anyway, for illustration purposes, pretend that didn't work. Huh, that's fascinating. But it also reminded me I should be using film numbers. Okay, pretend that didn't work. Right, it's a list. I really want to do something kind of with each element of this list. Okay, if I wanted to kind of give you an example where this wouldn't work, like this in this case would work, but if I wanted to know how many films each person had been in, right, asking for the length of that list column isn't the right thing to do, right? I don't want the number 87. I want for each element in films, tell me how long it is. And this is kind of a similar idea. For each element of film numbers, I want to create kind of this new string. So we know how to do that because we know about purrr. So we can, for each film number, each element of film numbers do something, and we could just paste. We could just do paste. It's not quite what I asked for, but we could do it. As it stands there, if I just use map, I'm going to get another list column back. I don't really want that. I want a character column, so I could try something like that. And there, oh yeah. That's, okay. Why didn't, does anyone, I know why that didn't work. Does anyone else want to have a guess why? Yep. Exactly. So paste, if you give paste a vector, you get a vector back. The way to take a vector and paste and make it into one string is to use collapse. So I'm going to just do this and then explain it in a second. So I'm going to add a collapse argument that's a comma and a space. So what was a little bit weird there though is this is my .x argument. This is my .f argument, paste. And then collapse is actually kind of in my dots. Right, that's in the it's in the dots for map, but that's going to get passed along to paste when it happens. So let's try that instead. That's better. Right, so now I can see that Luke was in film 6, 3, 2, 1, and 7. That's just a regular character column. I've kind of taken a list column and done a little bit of manipulation with mutate and got me back to a character column. So anytime you sort of have a list column in a tibble, but you want to take that list column and do something to it to get a normal column back, purrr is kind of one way to do that. Question? Yeah, so that's a great comment that really I should probably sort these film numbers in ascending order or something like that. So now I'm not going to be able to just pass and, well, like, there's multiple ways to do this, right? I could try and first create a new list column that's the sorted film numbers and then map again to paste them together, or I could do it all in one go. Let me do it all in one go. So I'm just going to change, instead of using a function name as .f, I'm going to use my shortcut. I'm going to paste .x. I'm going to collapse it, except that I'm going to sort .x first. And then match all my parens up. Always a challenge. Good call. The collapse is an argument to paste, not sort. So now I've switched to kind of using the shortcut because I'm doing something a little bit more complicated than just applying one function. I'm using the shortcut. I take an element of film numbers, so that's just an integer vector. I sort them in ascending order, and then I paste them all together with that same collapsing character. And I've messed up my parens somewhere. I forgot the closing paren for mutate. That's a little bit nicer. It might be even cooler to kind of just do a blank when there's not a film so they all line up. You can see who's in what, something like that. If you're interested in kind of following along with all of that, I believe, well, I don't do the sorting, but if you go to the GitHub for the tutorial, you'll find some code files that have most of the answers. If you're kind of trying to madly follow along with the code, you can find it there. Question? Yeah, good question. Yeah, so if you're not from, yeah, great question. So the question is essentially here, I'm not assigning this back to anything, and the question is, well, does that mean people underscore tibble has changed? And the answer is no. So nothing in mutate or dplyr changes that. It's just, I've just spit it out to the screen. I'm a little bit lazy and I'll often overwrite. Right, what I really should do if I want people tibble to change is to do that. Right, that's a little bit lazy because you can run into problems where if you run this line accidentally more than once and it's doing certain things, you really screw up. So that's a warning. You maybe shouldn't emulate me. Okay. Yes, second question. As data table, I suspect it is not as good as data table, but that's an intuitive answer backed up by, you should ask someone that knows more about data table and tibble. Okay, how are we doing? We've got about 25 minutes left. So these challenges here are sitting in the GitHub repo. They just sort of are code files where I've kind of laid out a task that I think you could solve with purrr. And they're designed to kind of emulate some of the things I've seen in practice where purrr has been helpful. And in particular, these work or are well approached by combining tibbles with purrr. So well approached by utilizing list columns to kind of keep everything nicely lined up. I don't think we have time to kind of work through them now, but like if you're tomorrow or next week, you want to kind of challenge yourself, go find these code files and you could work through them. So for example, there's kind of some stuff fitting and summarizing a whole lot of regression models. That's a pretty common use. Doing something with files in a directory. There's a Star Wars example. sort of a pretty common kind of data workflow. As you read in data, you tidy it, you plot it, and you save it out. There's an example of that. And then the data that we've been using, these hierarchical lists, I used the rwars package to get them, but I actually had to kind of use purrr to do that, just because of the structure of those files. So it's kind of almost cyclical. Okay, so all we really have to do for the last 20 minutes is talk about a few of the other iteration functions in purrr that you might find useful or might come across. And then I kind of have a very brief comment about other functions that exist in purrr that we won't talk about, and then we'll kind of just wrap it up. And I think hopefully we'll get through this and we'll have about 10 minutes or so for questions. Okay, so these are kind of all in the, we're not going to really work through any of these, but I'm going to tell you they exist in case you come across a case where you might need them. So the first function that we haven't talked about, but I did mention earlier, is this pmap function. So pmap is designed for the case where you need to iterate over more than 2 objects, right? Map's great for 1 object, map2 is great for 2 objects. Anything more than 2, you have to use pmap. And the way pmap works is it's pretty similar, except now that we have a .l argument and then a .f argument. So the .f argument is just like everything you've seen. You could specify a function, you could use this shortcut with the formula, you could use the strings or the integers. So the real difference is really the first argument .l. And it's called .l, it's not called .x for a reason, it's called .l to remind you that this has to be a list. And now this is a list of all the objects you want to iterate over. So if you give it a list with 2 things in it, it's going to iterate over 2 objects. So it would be like map2. If you give it a list with 18 things in it, then it's going to iterate over all 18 elements. And in the way, that is not intuitive to explain that. Oh, it kind of is. Okay, so what this line is trying to say is what happens, the result of pmap is like taking the function .f, well, this is the first element in the result from this pmap call, takes the function .f, or the shortcut, or however you've specified it, and it uses the first element of the first element in your list that you've provided as the first argument to .f. The first element in the second element of the list you provided as the second argument to .f, and then the first element in the third object you've specified as .l as the third argument, and so on. So the way, I'm going to kind of skip. The way I like to think about this is first that I think it's easier, instead of thinking of .l as a list, think of it as a data frame. And when you think of it as a data frame, it's the columns of this data frame are like the elements in that list. These are the things you're iterating over. It's useful to think of it as a data frame because a data frame forces all those elements to have the same length. That's going to be a requirement. If they're not the same length, you're going to get an error anyway. You might as well chuck them out a data frame to kind of verify that beforehand. And then, we kind of think of data frames as these rectangular objects. So I've got my columns here are my different objects I want to iterate over. And when I call pmap, the first thing I'm going to do uses sort of the first row of things I've specified. Here, what am I going to do? I'm just going to use C to kind of concatenate these things together. So the output is like taking the first row there. That's going to be the first element in my output. The second element takes the second row as all my function parameters. The third element in the output takes the third row of all my objects to iterate over. So as soon as you get more than 2 things to iterate over, you have to use pmap. The sort of downside, of course, is there's no formula shortcut here. You can't use a tilde and then have a .x, a .y, a .z, and so on, because there's just no way of knowing how many things you want to pass in. So now you have to either be using a function that already exists. You could write a function that does what you need to do. Those are your options. No shortcuts. The other iteration function we haven't talked about is invoke underscore map. Question about pmap? Yep.
So if I understand correctly, here once again you have only the option to go to first element, and then the second one, and so on.
Yep.
Is there any way to iterate on each object separately? For example, if I want to combine the element with the elephant with the heart and the mouth, or whale.
Essentially, no. There's not an easy way to do it. Yeah, so I mean the challenging part is kind of figuring how to line everything up. And I feel like there's sort of no automatic way to do that if you're going to do something like that. Like you're better off kind of describing how they line up and then describing that as these things of the same length and then passing it in. But we can, if you have a specific example, maybe we could talk about it later. Exactly. So, yeah. So essentially using expand.grid to kind of create this data frame that you're going to pass in, that then it's happening row by row. Okay, so this other function invoke map kind of switches things around. So instead of taking one object and applying a function to every element, you take a list of functions and you apply them to a single object. And that's kind of why the .f and the .x get switched around. I won't talk too much about that, but you can ask me about it. So the other things that purrr provides, the other functions in purrr that we haven't talked about, basically fall into two camps. They're functions that make working with lists easier, or they're functions that make working with functions easier. So the lists and the function are kind of these two objects that are key in everything we've seen, and there are functions in purrr that help you work with them. So for example, and this was a sort of a question earlier, these functions, safely, possibly, and partial, all take a function as input and output a function as output. And particularly safely and possibly help you handle that case where your function might result in error. And you don't want that error in one element to sort of cascade and mean that nothing worked. So you can sort of wrap these around one of your functions that gives you a new function that does exactly what your old function did, except it handles errors in a slightly different way. And if you're interested in that, I can certainly point you to some resources. And then there are these other functions, things like transpose, accumulate, reduce, every, order by. They all take lists as input and spit out lists as output, and they kind of help manipulate lists. Okay, we're doing good. So just to kind of wrap up, so purrr is essentially sort of providing these functions that write for loops for you. They help you solve iteration problems. They've got consistent syntax and then those convenient shortcuts for specifying functions to iterate. Choosing the right purrr function for your iteration problem is essentially depends on what type of iteration you're doing. Are you iterating over one object, two objects or more, or doing something slightly different? And then the type of output you want. So remember, the thing you get back, the type of object you get back depends on the function that you used, so those typed functions. If you want to learn more, here are some things that talk about it. So in the Alpha Data Science book by Hadley Wickham and Garrett Grolmond, there's an iteration chapter that talks specifically about purrr. And there's a mini models chapter that talks about that kind of interplay between purrr and dplyr, so using list columns and that kind of thing, particularly with models. The data camp writing function is an R course I have with my brother, Hadley, also talks about purrr in about 3 of the chapters. And then Jenny Bryan has a fantastic purrr tutorial as well that uses, that's where all those data sets were generated, and that's also really good. So just a reminder, you can grab the slides. They'll be up for a while. The GitHub has all the code, including the slides and answers and challenges and that kind of thing. You're welcome to, if you find typos, issue pull requests on that. You can find me on Twitter at cvwickham. I have a website. I have an email address. You can email me. I'm only half-time a professor, so the other half-time I do consulting if you have any things you want to pay me to do. Otherwise, that's it. So we do have time for maybe we'll do sort of 5 minutes of general questions, and then I'll let you all go, and you can come talk to me if you have more specific questions. In the third row first. Yep. Yeah, so the question is, I said something about expand grid functions in purrr. I believe they're there. I can't tell you the names right now. So how I'd find out, I'd do help package equals purrr, and I'd read through them all. You'll find it. Another question? Mm-hmm.
I had to do something similar with 60 or 70,000 files. And we had a script running and it was going for more than 24 hours, and then we just changed the thing. We just called system, and we were practically appending the rows we were having to each file to a single TXT file. And that was much faster. It finished like in 20 minutes. How map or map 2 compared to just calling system?
That's a good question. So how does, yeah, I mean, I guess my general advice would be, like it's, repeat the question, sure. So it was a complicated question. So I guess the question is, there are examples where it can be a lot faster to call system repeatedly, say, or call system that calls a loop, to do something like the file manipulation we saw in the map2 example. And what, I guess the question is, when does that happen, or why, like...
We can think the same example, but instead of just 3 months, you have
Yep.
all months for 30 years.
Yep.
And that's nothing still, because if you have like 100,000 files being created over, I guess that this would still be slow.
Yeah, so I mean, I think the general advice is that, you know, performance doesn't really matter until it matters, and then it really matters. So if it does matter and it's a problem, like, I mean, I would always, if I'm doing an iteration problem, I tend to go to purrr first, right? And if it works in a time that's reasonable for me, it's done. And if it doesn't, then I've got to think, is this a problem with purrr? Is it a problem with what I'm doing on each element? And yes, it could be that, you know, I think, so one way the good thing about sort of doing this with one element first is that you get a chance to look at what you're doing on one element and ask if that's the most efficient way to do it. That's kind of one thing to look at, and then of course, it could be that what you're using purrr to do could be done much faster with something else. I don't think there's sort of a general way to solve that except to consider it as a possibility. So maybe one more question and then we'll leave in the red shirt.
Well, I have a teaching client who says that whenever you are tempted to use map2 or PMap, don't do it. Put your data in a data frame, and because that is just for safety and for better overview. Do you have an example where this fails?
That is a good question. So the question essentially is that almost everything you do with map2 or pmap, you should really replace with data in a data frame and doing something, I assume, with mutate or something like that. I don't know. I think that's a great point. I think that as soon as, like, map2 and pmap require you to have these things you're iterating over that are of the same length. And that's kind of a sign that things should be in a data frame, that you really have this correspondence and you should be maintaining that correspondence explicitly, not implicitly with these two objects that just happen to be the same length. So I mean, I think that is great advice, and I'll have to think if there's a counterexample, but I can't off the top of my head.
This question predates map 2 or if this level the same argument on regular lists.
Yes, so the comment is that this isn't really a question about map or PMAP, but just about whether you keep things in lists or data frames, and yeah, I think you're right, that is an older question. Okay, so if you still have questions, I'm around, I'll be around for lunch, come talk to me. I have the stickers, I'm sure you've all been waiting. I'm gonna leave them on this table. I think I have about 200 stickers, so there's definitely enough for one each, but probably not enough for two each. So only take two if you really want one, or really want two. And you should be able to hunt down the RStudio desk, and they should have more if you need more. I also have 4cat stickers, which is another hex sticker from the Tidyverse that has cats on it. But you have to come talk to me to get those ones.